This will be a review of the introduction to functions. Before we get to actually what a function is, first let's start with what a relation is. A relation is a collection of paired inputs and outputs. So some input leads to some output. That is a relation. Now, for it to be a function, there are two special conditions that must be met. I'm going to give you kind of an informal way of thinking of that, and then the formal definition that you might see more in an Algebra 1 textbook. So the one requirement that must be met is that all inputs are defined. Or you could even say it even more simply, all inputs have an output. A formal definition will look something like this. It will say, for every value in the domain, there is a corresponding value in the range. And we haven't talked about all those words yet, but that is what we could say for the definition more formally. There is a second requirement that we need for a function, and that is there's only one output for each input. A more formal way of saying that would be that there is a unique value in the range for each value in the domain. So when we actually take a look at what that's going to mean, hopefully it'll make a little bit more sense to you. Okay, so let's look at these two examples. Here we have an input-output map, and so we can see inputs are connected to outputs, like -8 goes to 13, and -6 goes to 4, and so forth. So we ask ourselves basically the two criteria, are they met for this? Does each input have an output? Well, basically I see a line coming out of each of the inputs, so we meet the first criteria. And then we ask ourselves, is there only one output for every input? So -8 only goes to 13, -6 only goes to 4, +3 only goes to 5, 5 only goes to 9. Now 10 going to 9, that's okay. That might throw some people off and make it think it's not a function, but because 5 has one place it goes to and 10 has one place it goes to, it doesn't matter that they're going to the same place. So we'd say yes, and because every input has one and only one output. Okay, so let's look at this second example. We're asking ourselves again about those two criteria. I see that -8 has an output, -6 has an output, 3 has two outputs, 5 has an output, and 10 has an output. So, does every input have an output? Yes, everything goes somewhere, but if we look closer at -6, or I'm sorry, strike that. If we look closer at 3, we see that it has two different outputs, and that's a problem. So no, and we would say because the value 3 has two outputs. So real quickly, let's look at one example over here and see about the other way that we might not have a function. So there's the giveaway. If we're looking at this function, we see 8 has an output, -6 has an output, 3 has an output, 10 has an output, but 5 goes to nowhere. So this would be no, this breaks our first condition. No, because the value 5 has no output. In addition to wondering if a relation is a function, we also then want to know if the function is many to one or one to one. So here we're going to look at 4 different examples. Okay, so first thing we want to know, is it a function? So if we look at example 3 here, we're looking, does every input have an output? Ooh, no, 3 does not. So this is not even a function. So not a function. It breaks the condition that every input must have an output. So no, 3 has no output. Okay, we look at example 4. Does every input have an output? 1 does, 2 does, 3 does, 4 does. Does every input have only one output? Oh, no. 2 has 2 outputs. So no, we would say 2 has 2 outputs. Okay, now let's look at 5. Okay, 1 has an output, 2 has an output, 3 has an output, 4 has an output. Does every input have just one output? 1 only goes to one place, 2 only goes to one place, 3 only goes to one place, and 4 only goes to one place. So yes, this is a function, but now what type of function is it? So we're asking a question about many to one or one to one. So we see that many to one means many inputs go to one output, and if it was one to one, that would be one input for every output. So we see here that 1 and 2 both have the same output, so we would say this is a many to one. Many inputs are going to one output. Okay, with our last example here, we first want to know if it's a function. 1 has an output, 2 has an output, 3 has an output, 4 has an output. Any inputs have 2 outputs? Nope, everything's just kind of going one line out of the inputs. So yes, it's a function. But now let's think about what type of function. Do any of the outputs basically have 2 inputs that lead to it? A only comes from 3, B comes from 1, C comes from 2, and D comes from 4. So this one is 1 to 1. We may also see functions not written in maps but in ordered pairs. So here we see a set of ordered pairs in each example, and we're asked first, is it a function, and then second, what the domain and range are. We're going to get to that right after we first look at the first example to determine if it's a function. So in this first example, I see 1 goes to -2, -2 goes to 0, -1 goes to 2, and 1 goes to 3. So if you notice here, 1 shows up in the first and in the fourth ordered pair, and it goes to 2 different places. And that breaks one of our conditions of whether it's a function or not, because we have one input going to 2 different outputs. So no, this one's not a function. But we can still address whether what the domain and range are. So the domain is all the possible inputs, or x values more commonly. So we're going to list these in order from least to greatest, and we're not going to do any repeats. So the smallest input is -2, then -1, and then 1. We don't need to list 1 twice. And then the range is all the possible outputs, or most commonly y values. These should be curly brackets. I'm having trouble drawing them on the iPad. So let's again go from least to greatest. -2 is the smallest. I see 0, 2, and 3. And so that is the domain and range for this set of ordered pairs, and in this case this was not a function. We can also assess whether a graph of a relation is a function or not. So if we think about the terms of being a function, one of them was that every input has an output and that there's only one output for every input. So on a graph, outputs are y's typically and inputs are x's. So if there are 2 outputs, 2 y values for an input, the graph would have to kind of double back on itself. So what we can do is we can do what's called the vertical line test. Vertical line test. So if we can draw a vertical line everywhere on the graph, let me make that a little bit bigger here. Any vertical line on the graph that we draw can only cross the graph in one spot. If that happens, then yes, it is a function. So if I look at this first example, will any of the lines that cross it hit the graph twice? No, none of those lines hit it twice. So yes, this is a function. And now we're going to assess what the domain and range are, and we're going to use an inequality to express this. So we're going to look at first the domain, and that's the x value. So the smallest x value is -9. So -9. And now that's an open circle, so that's just less than. And then it's going to go all the way to +8. So -9 is less than x is less than 8, and that would be the domain. Then for the range, we're going to look at the y values. So if you're here, look from bottom to top. So the smallest value is -5 right here, and it goes all the way up to 3 right here. So -5 is less than, this case, less than or equal to, I'm sorry, this has an equal to too, right there, y, which is less than 3. Okay, so again, if you caught that, this has a less than or equal to because of this closed dot, and this has a less than or equal to because of this closed dot. When it's an open dot, we get the strictly less than symbol. So that's the domain and range for this function, which does happen to be a function. So let's look and see if we can find another example that's not a function. Okay, so I'm actually going to start off with example J and then come back to some of these other examples. So if I look at example J and I were to draw a vertical line here, well, that crosses once, but if I draw a vertical line here, we're going to cross that graph multiple times. So basically that's one x value, that vertical line represents one x value, and there are multiple y values that exist for this relation. So this is not a function. Okay, we can still address the domain and range, but this one is basically the same example as the last, and I'd really like to talk more about an example like letter G here. So in letter G, hopefully you can tell pretty quickly that this is a function. All the vertical lines that we would draw would only cross through it once. So yes, it is a function. Okay, now for the domain. Let's first talk about what is the smallest x value. It seems to be going to the left forever. That's what this arrow means. So there is really no smallest x value. It would be like -infinity. So what's the biggest x value that we could have? That would be 9. So x just has to be less than 9. So it's a one-sided inequality as opposed to a compound inequality like in the previous example. Now with the range, again, look from bottom to top. The smallest x value, smallest y value this time is -3, and that's less than y. And now is there a biggest value? So we look, and the arrow is not only going to the left forever, but it's also going up forever. So there is no maximum value for the range. So it is, again, is a one-sided inequality. Don't be thrown off in example I here, especially when looking for the range. So students will often focus on kind of the endpoints, the circle here and the arrow here, but when you're looking at the range for this example, make sure you really think about where's the lowest point of this graph. The lowest point of this graph is right there. So it starts, the range would be -6 would be the smallest value, is less than y, and then this one goes up forever. So that's the range for that one. So watch out for when the endpoints are not necessarily the maximum or minimum value of the domain or range.